Hello everyone, good afternoon and welcome to our today's webinar. I'm delighted to have you all here with us. We have an exciting and insightful webinar here featuring one of our software engineers, Sabbir, as the speaker. He has been involved with the managed Apache Cassandra project for a while. So before we begin, I just want to mention you that your participation and engagement are very important to us. If you have any questions during the webinar, please feel free to ask them in the Zoom chat. We will address them during the QA part of the webinar. Without any further delay, let's dive into the program. Over to you, Sabbir. You can continue.
Hello everyone, I'm Sabir Hussain, software engineer at AppsCode. So in this webinar, we are going to go through provisioning Apache Cassandra on Kubernetes using KubeDB. So let's start. These are the table of contents. First of all, we will have a short overview of Cassandra. After that, we will see features and specifications of Cassandra. Later, we will discover the architecture of Cassandra. Then we will see how provision Cassandra happens in KubeDB. After that, we will see a live demo. And finally, we will have a Q&A session. Okay. So what is Cassandra? Apache Cassandra is a highly scalable distributed NoSQL database designed for handling large amounts of data across many servers with no single point of failure. It offers high availability, fault tolerance, and horizontal scalability, making it ideal for applications requiring real-time data access. So one of its features is distributed architecture. Apache Cassandra's distributed architecture uses a peer-to-peer model where nodes are equally responsible for data storage and processing. It ensures high availability, fault tolerance, and scalability through replication, partitioning, and a ring-based topology. Then its querying is very similar to SQL. The Cassandra uses CQL, which means Cassandra Query Language. Queries are optimized for fast lookups using primary keys and clustering columns with limited support for complex joins and aggregations. Its another important feature is its high availability. As Cassandra maintains replication, Cassandra ensures high availability through data replication across multiple nodes and automatic failover. Its masterless architecture allows continuous operation, even if some nodes fails. It is a NoSQL database, so it has all the benefits of a NoSQL database. Again, fault tolerance. Cassandra ensures fault tolerance through data replication across multiple nodes. If a node fails, others automatically take over, enabling continuous availability without data loss. And another feature is scalability. Cassandra offers linear scalability by allowing seamless addition of nodes to a cluster. Data is automatically distributed and balanced, enabling consistent performance as the system grows. Okay, let's go through the architecture of Cassandra. So Cassandra's architecture consists of node, cluster, data center, and rack. Okay, so if we consider a node, it is a single instance of the database. Okay. A rack is a logical grouping of nodes within a data center, typically representing physical server racks. Cassandra places replicas on different racks to reduce the impact of hardware failures. Now, what is data center? Data center is a collection of racks, often representing a physical or cloud-based data center. Multiple data centers can be used for disaster recovery, geographical distribution, and load balancing. So here we can see there are, in this Cassandra cluster, there are two data centers, and within data center, there are two racks, and in every rack, there are two nodes. Okay. So while using KubeDB, how the provisioning of Cassandra happens. First of all, a custom resource is created. The KubeDB operator watches this custom resource and automatically creates pet sets, services, secrets, app binding, and so on. Okay. And KubeDB uses four types of deletion policy. While we try to delete Cassandra, there are four options. First one is halt, which means when we apply it, secrets and PVCs are not deleted. Others get deleted. Another is delete. It deletes everything except secrets. Another is wipe out. This deletes everything, including PVC, secrets, and so on. Another is do not terminate, which is it reject the deletion. So when do not terminate is used, then the database will not get deleted. Okay. So this is how we can install KubeDB in our cluster. First of all, we need to mention the version. We need to mention the namespace where we want to install it. And we need to specify the path of the license. Okay. Now we will see a live demo. Okay, so for simplicity, I have already installed KubeDB in KubeDB namespace. So it is in KubeDB namespace. Okay. For simplicity, I also uh, installed Cassandra in demo namespace. Here, two ports of Cassandra are created. While creating Cassandra operator, this services has been created. If we try to see the secrets, these two secrets has been created. So this is the authentication secret. Again, these two ports, this creation takes approximately 2 or 3 minutes. Um, so for saving time, I have applied this earlier. Okay. Now, if I want to see this secret, okay. So there is a password and a username. Okay. And this is in base 64 format. If I want to see it, then echo. Let's say we want to see the password. The password is this. If we want to see the username, okay, so admin is the username. When I will try to access the SQL, then I need to provide the password and the username. Okay. Now let's say we want to access its SQL. Okay. If we don't provide any password, then it will show some connection error. Okay. Okay. Now we will create a key space here. Here we have used simple strategy and replication factor is 1. Okay. Now we will use this key space. The name is my key space. Okay. Use my key space. We can create a table and can insert data. Okay. Now we want to view this data. Okay. we have used this YAML. Here we need to specify the name and namespace. The namespace was demo here. Then we need to mention the version. We have two versions, 5.0.0 and 4.1.6. Okay, so 5.0.0 is used here. Then we need to mention the racks. There are two racks, rack 0 and rack 1. In rack 0, there are one replica. A storage type can be durable or ephemeral. We have used ephemeral here. We can also use durable here. Okay. Then this is for the first rack, and again this is for the second rack. We can change the replicas here, but each time we add a new rack, we need to specify the name of the rack and then define everything. Okay. So, any question?
So I guess that's all from your end, Sabir, right?
Yes.
Okay. So we have come to the end of today's webinar. Thanks, Sabir, for the fantastic explanation with his hands-on demo. If you have any queries, feel free to ask now in the Zoom chat. I guess there is no question at this point. Thank you all for your participation, and we look forward to your presence in our future sessions. Visit our website appsco.com/webinar to check the upcoming schedule and register for upcoming events. Wishing you all a very great day. Bye bye.